Hello, internet. I think there are human beings behind those screens, so let me stop calling you internet. I should start calling you the names that you deserve. Hello, ladies and gentlemen, boys and girls, grandpapas and grandmamas. I have a new mic. We have a new mic, and that means that we shall be having good quality content and good audio. So subscribe and hit that like button so that you don't miss the good quality content. Today we are going to look at pygwalker. So let's get started. Pygwalker is a Python library that can help speed up data analysis and data visualization directly within Jupyter notebooks. It is very similar to Tableau, and you can integrate it into Streamlit and build analytics apps around it. In this video, we shall build a simple analytics app using pygwalker and Streamlit. As part of the culture of this channel, I will show you how I create the whole environment so that you can set up everything on your PCs as you follow along. I have a working folder here on my desktop named pygwalker, and inside it I have a subfolder called data, and inside the data folder I have a CSV file containing data about the latest data science salaries. This data I downloaded it from Kaggle. You'll find the link in the description. Let's launch our terminal and move into our working directory. So cd to desktop, then our working directory is pygwalker. Have cond activated. I'm just going to deactivate it. This is not necessary for this video. So inside this working folder, it's where we are going to write our code. Let's determine the Python version that we shall use in our project, and we are going to specify that Python version within our working directory. So I'm going to use pyenv to do that. Pyenv local. I'm going to be using Python 3.10.0. You can use any other Python version. I think greater than 3.8 I think will work. So if I try to list everything within our working directory, you can see that we have a Python version here. We can then create a Python virtual environment. So Python -n vm. And then after creating this Python virtual environment, we can activate it. So source bin activate. If you are using Windows as your operating system, I've left a link in the description for you to create a virtual environment and activate it. Now that we have the virtual environment activated, we can install the necessary packages using pip. So pip install pandas, because we are working with data. Then we have Jupyter Lab. I prefer Jupyter Lab than Jupyter Notebook, pygwalker, and Streamlit. This is going to take time depending on the speed of your internet. Installation is done, and we can now launch the Jupyter Lab. So we're going to launch it within the working directory. So I'm going to type here Jupyter Lab, and this is going to launch in the browser. The folder is here, and we can now work with Jupyter Lab for the rest of the project. Since Jupyter notebooks are used to do data experiments, I'm going to create a folder called Lab, and within this folder is where we put all the Jupyter notebooks for this project. But for the case of this video, we're going to have only one Jupyter notebooks. But this is just my own convention, where if I find a folder called Lab, it will have Jupyter notebooks because it's where I'm doing experiments from. So within this Lab folder, I'm going to create a new Jupyter notebook file or a notebook file. Then I'm going to name this dashboard. And let me make it bigger so that things are clear here. Let's import now. I'm going to close this. Let's import now pandas and pygwalker. Import pandas as PD. Import pygwalker as pyg. Then let's import our data. So data is going to be pd.readcsv, and then the path to our data. So our data should be inside the data directory / this is not identified, so one step back /data / that. And let's take a sneak peek onto what we have. So we say that this data is data about the recent salaries of people working in the field of data science. So we have job title, employment type, experience level, expertise level, salary, currency, company location. You can find this data through the link in the description. We are going to use this data, but we're going to subset where salary in USD is less than $1 million to eliminate outliers. So data, where data, this column is salary in USD. I'm just going to copy it. This is too huge, make it small. Salary in USD is less than $1 million. Yeah, so I've seen this data before, and there are some outliers where salary is far much greater than $1 million. And that's why I'm chopping it out. Then we are going to use the work function for pygwalker so that we can launch our dashboard within Jupyter Notebook. So pyg.work, and we are working the data. So this, let me maximize this window. This is giving us an interface that looks like Tableau that you can interact with to visualize your data. Let's explore the interface that the work function launches here. So we have two tabs. We have visualization tab and the data tab. The data tab shows all the features in your data set, or you can call them columns, and the records. It also tries to guess the data type and the kind of the data that each column contains. So like this index here is quantitative, but I think it is not quantitative, it is nominal. Then the job title is dimension, which is also nominal. I think it is nominal, yeah. Then we have employment type. It tries to guess. You see the salary here is a measure, and it is a quantitative measure, so that like a number, and so forth. Then we have this other part, which is where you plot your visuals, and we are going to plot 2 to 3 visuals just to get used to this interface. So let's plot our first chart. And in our first chart, we're going to look at salary in USD, then we split it by employment type. And we see we cannot resize this chart, so you need to change the layout mode to fixed. Then now you have a freedom to resize the chart to any size you want. Then the aggregation level for the measure here is sum. You can decide to make it not to have any aggregation by clicking this button. But for us, we want to aggregate it, and what I want to aggregate this with is mean. So I'll select this, and we have the average salaries per employment type. Then we can click this button to sort. And this, you can see here that people who are employed full-time, data scientists, receive more salary on average than contractors, freelancers, and part-timers. Let's rename this chart to salary in USD by employment type. Salary by employment type. So we have a chart here, salary. We can now create a new chart here in another tab. And this time around, I would like to see still salary in USD because it's the only measure here. But I want to see it by the level of expertise, and we are going to change this to fixed, make this chart a little bit longer. Then I'm going to transpose to make it horizontal, and I want it sorted. So we can see experts receive more salary, but let's change first the aggregation level to mean, average. So you can see sums in average. So directors receive more salary. That means that you have to be director so that you can receive more money. And then experts, then intermediate, then junior. It's just normal based on how you climb the corporate ladder, the more salary you receive. So we have this. We can rename this chart to salary by expertise, maybe expertise level. Then the next chart, I would like to work with the box plot. So I'm going to have this, the same thing, next this and fixed. Make it bigger like this. Then I want the chart to change the chart to a box plot. Then the salary. So it has aggregated to a single value here because the aggregation level is sum. So I'm going to remove the aggregation level, and now we have the box plot. We still have some outliers here, but it was not as big outliers as the ones that we were having. Then I'm going to color these items in the box plot so that I can see the level of expertise. So we can see that the directors on average receive more salary than the experts. Then the junior are down below the box plot. We can also split, instead of level of expertise, we can split the x-axis on the experience level. So now we have entry level. We can see in fact, all of the entry level data scientists are junior, close to all, because I can see some intermediate here. Then we can also see the executive are also directors, and we can see the mid-level data scientists are intermediate expertise, then the senior are experts. So you have to be an expert for you to be a senior based on this data set. So this is our dashboard. We have not renamed this. We can just call it box plot. So this is our dashboard. It has 3 visuals. We can do much more based on the features that are here, but based on this simple dashboard, we can try to deploy it using Streamlit, and that is what we're going to do now. So the next thing that we're going to do is to go back to our root folder, and I'm going to create a new folder called app, and in this folder I'm going to create a new file, a new Python file, and this file I'm going to call it pygwalker dashboard app. Then the second file I'm going to create here will be just a constants file, and I'll show you why I'll create this file. So a Python file, I rename it to constants.py. Then now that we have pygwalker dashboard app.py and constants.py, we can go back to our dashboard. And now we are going to export these settings that we have created here, the settings for the dashboard and everything. So you click this button here, it is called export code. So when you click on this button, this interface appears that shows you the visual specifications for the dashboard. I'm going to copy to clipboard, then I will open the constants.py file, and I'm going to paste that code that I have copied into the constant. So I have my variable here that contains the visual specifications for the dashboard that we have created here. So these visual specifications is what we are going to import into the pygwalker.py file, and we shall embed it into the Streamlit app. So I don't need this because I'm going to include it into the pygwalker app file. Next, let us work on the dashboard app. So let's start by importing the packages. We're going to import pygwalker. Import pygwalker as PYG. Pygwalker as PYG. Then we're going to import pandas. As PD. Then we're going to import components for Streamlit so that we can have visual components, and the component is going to help us to use dashboard as a component. So import Streamlit .visual.component v1 so .components .visual1 as components. Then we are going to import Streamlit as st. Then we want to use these visual specifications that we created from this dashboard. So from constants, import visual specs. I'm just going to copy the variable. We're only importing the variable. So now let's work on the page on the Streamlit. So streamlit.setPageConfig. And within this, we want the page title. I'm going to set a page title. Page_title. And the page title, I'll call it Recent Data Science Salaries. data science salaries. Let me capitalize each one. Then I want the layout to be wide. Layout equals to wide. Then we're going to add a title inside the page. So streamlit.title. I want the same title as the page title. Then I'm going to import the data. So my data frame is going to be the same importation as the one we did here. But we are most likely going to run this application from the root directory. So I'm going to just call the data folder directly. If it fails, then we shall try to move back. Then we're going to have our pygwalker HTML component. So pyg HTML will be the same as what we did here. So it is pyg.walk, but we need to define, this is the data frame df, we need to define the visual specs. So the spec will be equal to what we imported here. Remember, the visual specs we created, these are the ones that we copied from the dashboard that we created here, so that we don't lose the work that we have so far done. Then whatever we are returning HTML. So return HTML equals to true. So it's going to return like a HTML code. So here we have generated HTML. Then now we are going to append that HTML to our components. So components.html, and this is what we want for inside the HTML for component. The height, let's keep it as 1000, and scrolling, we should enable scrolling equals to true. So this is how you can define the dashboard using Streamlit. We can now try to run this dashboard from the terminal. The good thing with Jupyter Lab, you have terminal available here. So I can do, let me first remove my conda, deactivate. I don't know if it is clear. Let me use the terminal that we used before. So we are going to kill Jupyter here. Then within the root directory, or the root folder for our project, we can run the Streamlit app. So I'm going to do Streamlit, then run, and the Streamlit app is inside app, and inside app we want to run pygwalker.py. So when we run this, it should be able to run the server for pygwalker inside, the server for Streamlit, and embed our dashboard. It has run it, it is here. And now we can see our dashboard is ready for serving. It is running on localhost 8501, and everything we did before is inside here. Plus, someone who is interacting with this dashboard can add extra charts. For example, salary in USD, and then making a stacked bar chart, expertise level being the color, then changing the size. This is now happening on the app itself, changing the aggregation to maximum maybe, and then ordering. You can see people were receiving maximum charge. We can transpose, but this is not saved. It does not automatically save to Visual Specs. What I would like Pygwalker to do is to have a button here where if someone clicks save, then that that data goes into the Visual Specs that we downloaded. But if you refresh, for example, if I refresh this now, we shall lose the chart that we've created, but is not in the Visual Specs. So this is what I wanted to share to do with Pygwalker. If you've learned something, please don't forget to share with someone who you think will find this interesting. Leave a like button so that the YouTube algorithm can share this content with more people. Subscribe if you have not. I have a lot of content to share with you and a lot of things that I think we can learn together within this community. Until next time, take care of yourself.